Hi, in this video I'm going to be talking through the anatomy of the brainstem. So first of all, we can break the brainstem into three sections, and on this anatomical diagram on the right, you can see that we have at the top the midbrain, then our pons, and then at the bottom our medulla. On this diagram on the left, this is how I like to draw out the brainstem, as it allows you to visualize we have at the top the midbrain, then pons and medulla. And I find this an easier way to draw out the diagram and then visualize where the brainstem nuclei sit. So, we have a few key landmarks when we look at the brainstem that it's helpful to know what they are and have an idea of what they do. So first, we have on the anterior side our cerebral peduncles, and these sit on the anterior part of the midbrain, and these contain the descending motor fibers from the cortex. We then have the olives, and these sit on the lateral part of the medulla just here, and these are the olivary nuclei play a role in the auditory system. And we have our pyramids, and our pyramids run down through the medulla, and these contain things like our pyramidal motor tracts, such as our corticospinal tract. And this is again a continuation of our motor fibers, so they come down through to the cerebral peduncles and then down in the pyramids. They then also will decussate in the pyramids, and that's why we also have our pyramidal decussation, which isn't clear on this image, but they will decuss around here. On the posterior side of the brainstem, we have our superior and inferior colliculus, and these are these lumps we can see here, so superior and inferior, and they play a role in our visual and auditory systems. We also have our cerebellar peduncles, and this can be seen as this flat area here, and this is where the cerebellum will attach to our brainstem, and it sits on the back of the pons. And then we also have our dorsal columns, and these sit posteriorly, hence the name dorsal, and there are ascending sensory fibers, predominantly from our dorsal column pathway. So the next thing we want to think about is the blood supply to our brainstem, and we can break this up into a few sections. So if you familiarize yourself with the general blood supply to the brain and the circle of Willis, this will help first. And then you can start to look at each section. So in our midbrain, we have the anterior part, which contains part of our, I think that's posterior. We have our posterior part, which has our superior cerebellar artery. We then have our anterior part as part of our posterior cerebral artery. And you can see each of these here, so our superior cerebellar artery and our posterior cerebral artery. In the pons is simple, and its blood supply comes from the basilar artery, which comes up the middle here, and the branches that come off it, which are called pontine arteries. So the blood supply of the pons is easy to remember. The medulla is slightly more difficult because it has different blood supply at different points. So at the top of the medulla, we have the pica, which is our posterior inferior cerebellar artery, and this supplies the posterior part of our upper medulla. We then have this middle part by our vertebral arteries, and then we have our anterior spinal artery, which we have just one of as it joins from the two, doing the front part. And the anterior spinal and vertebral arteries also do the lower medulla, and the posterior part is made up of our posterior spinal arteries, which come off of our pica, just lateral to where you can see on the diagram. So this is important to remember, as things like vertebral insufficiency and problems with the pica can lead to lateral medullary syndrome. And this is something where you have loss of the function of the brainstem nuclei in this region. And in a second, I'll be going over the positions of the brainstem nuclei so you can work out what these lesions would cause. So for remembering the brainstem nuclei, whilst you can try and remember the whole diagram, I find it's easier to first remember a few simple rules. So first, we have that cranial nerves 1, 2, and 11 don't have nuclei within the brainstem. This is because cranial nerves 1 and 2 are completely cortical, and cranial nerve 11 is spinal. The parasympathetic cranial nerves can be remembered by the sort of number 1973, where you have to remember that cranial nerve 10 is the one at the start. And then you also have, similarly, 1972, which is the way of remembering the clotting factors in the coagulation cascade, which are vitamin K dependent. So that's two things that you don't want to get confused, but because if you remember one, it's easier to remember the other. So it's important to know which ones are parasympathetic, because each of our parasympathetic cranial nerves has both its own motor nucleus and it has a parasympathetic motor nucleus, because it has two different functions. The motor nuclei, which sit in the midline, are all factors of 12. So this means that if you multiply them by another number, you get 12. So 3 sits in the midline because 3 times 4 is 12. 4 sits in the midline because 4 times 3 is 12. 6 sits in the midline because 6 times 2 is 12. And 12 sits in the midline because 12 times 1 is 12. So obviously 1 and 2 are also factors of 12, but as we've already established, they don't have brainstem nuclei. So the ones in the middle are 3, 4, 6, and 12. On the sensory side, we've only got 3 nuclei, so that's a much easier diagram to remember. And we have 2 of our main nuclei which have slightly odd names, and these are our nucleus solitarius and our nucleus ambiguus. And it's easier to remember that solitarius is the sensory one because they both start with an S. So first I'm going to go over the sensory nuclei, which, as I said, are easier to remember because there's only 3 of them. So this is where they sit. We have this long blue one running all the way down. We then have our red one, which looks somewhat like a baby's dummy. And then we have a long straight one sitting just in the medulla. So this long blue one is our cranial nerve 5 nucleus, and it has 3 different sections. And this is to do with the different functions of cranial nerve 5. So we know that cranial nerve 5 gives proprioception to the muscles of mastication, and this is done by this top part, the mesencephalic nucleus, where the mesencephalon is also another name for the midbrain. We then have our pontine or chief nucleus for the middle part of our cranial nerve 5 nucleus, and that gives us our touch sensation from the face. And then the bottom part is called the spinal cranial nerve 5 nucleus, and this provides pain and temperature sensation, again from the face. So the blue one is our cranial nerve 5 nucleus with its 3 parts. We then have our red vestibulocochlear, which is our cranial nerve 8 nucleus, and this provides information on balance and hearing. And as you can see, this crosses over the border between the pons and the medulla. And then finally, our green one just sitting in the medulla is the other sensory nucleus that we've already mentioned, the nucleus solitarius, because it begins with S. So this has our taste sensation, because that's, again, a sensory input from cranial nerve 7 and from cranial nerve 9. It also has our pharynx and larynx sensation, which come from our cranial nerves 9 and 10. and it has input from the respiratory receptors, and these are again cranial nerve 9 and 10 input. And that's as simple as the sensory nuclei are. So if you can remember that, you know the sensory side. There's slightly more going on the motor nuclei side, but hopefully they're not going to be too difficult to remember. So as we've said, our cranial nerves 10, 9, 7 and 3 are each going to have 2 nuclei. And this is because they are parasympathetic. And we then work downwards. So as we've said, 1 and 2 are off the top because they don't have nuclei within the brainstem. Cranial nerve 3, however, has a parasympathetic part, and that one comes first. And this is called the Edinger-Westphal nucleus, and this is the parasympathetic part of cranial nerve 3. And the parasympathetic part of cranial nerve 3 plays a role in the pupil constriction reflex. Then we have our cranial nerve 3 nucleus, and these two both sit in the midline because the number 3 is a factor of 12, so it sits in the midline. Next up, we have our cranial nerve 4, which is from our trochlear nerve, and this again sits in the midline because 4 is a factor of 12. Next we have our cranial nerve 5, which sits slightly further out, and this has its motor part to the muscles of mastication. We then have cranial nerve 6, which is our abducens nerve, and this again sits in the midline. And our cranial nerve 7, which again sits slightly further out because it's not one of the factors of 12. Cranial nerve 7, however, is one of our parasympathetic nuclei, so that means that it's going to have a second nucleus. And this is here our superior salivatory nucleus. And our superior salivatory nucleus is the parasympathetic part of 7, and it causes salivation from our sublingual and submandibular glands, and it causes tears from our lacrimal gland. So if this is our superior salivatory nucleus, then unsurprisingly the one just below it is called the inferior salivatory nucleus, and these two sit just either side of the pons medulla junction. And the inferior salivatory nucleus takes motor to the parotid gland, and that causes salivation from there. So in the medulla, we have these 3 long straight nuclei. The first of which is called our nucleus ambiguus, and this is the main motor nucleus for our cranial nerve 9 and cranial nerve 10. So although I said each of the parasympathetic ones has 2, cranial nerves 9 and 10 do have a shared nucleus, but it's a long one. Following on from this, we have, well, cranial nerve 10 is parasympathetic, so it's going to be the parasympathetic part of our cranial nerve 10. And this is called the dorsal motor nucleus of the vagus. And this supplies things such as our motor to our GI tract, which has parasympathetic supply. And then finally, as we've said, cranial nerve 11 doesn't have a nuclei, so we have our cranial nerve 12, which is our hypoglossal nerve, and this provides motor supply to our tongue. So if we were to bring all of this together, we have on our sensory side just 3 nuclei, which can be broken into, with the cranial nerve 5 being broken into 3 parts, and then our vestibulocochlear and our nucleus solitarius. On the motor side, we have our Edinger-Westphal and our cranial nerve 3 in the midline because they're factors of 12, as is 4, so that's also in the midline. We then move down into the pons, where we have cranial nerve 5, cranial nerve 6, which sits in the midline, and cranial nerve 7, which sits further out. But cranial nerve 7 is parasympathetic, so it has the superior salivatory nucleus. Next, we have the inferior salivatory nucleus, and then we have our nucleus ambiguus, which is cranial nerves 9 and 10. We then move into our dorsal motor nucleus of the vagus, and we have our cranial nerve 12. On the sensory side, we've got our cranial nerve 5 nucleus, which is broken into the mesencephalic nucleus, the chief or pontine nucleus, and the spinal nucleus. Then we have our vestibulocochlear nucleus, and our nucleus solitarius, which has taste from cranial nerves 7 and 9, and the sensation from your pharynx and larynx. So the last thing to talk about in our brainstem is the reticular formation, and this can be slightly complex and confusing. So I'm going to start talking about the basic anatomy of the reticular formation. And we have these Rafe nuclei, which sit in the midline, as you can see here. And these produce our serotonin. We then have our locus coeruleus, also known as our cerulean nucleus, and these will produce our noradrenaline. We have our ventral tegmental area around our ventral tegmental nucleus up at the top, and these produce dopamine, and if you're familiar with the dopamine pathways, these play a role in our mesolimbic and mesocortical pathways. And we have our pedunculopontine nucleus. So this will sit between our peduncles and our pons, and they sit just adjacent between the adjacent to the nuclei. So they'll sit in this area, but they aren't shown on this diagram. So, and this produces our acetylcholine and our glutamate. So the main role of the reticular formation is in your sleep-wake cycles and how awake you are and alert you are at various times. So when you're meant to be asleep, your midbrain Rafe nuclei will produce serotonin, and then in the hypothalamus, this produces a molecule that causes you to go to sleep. You also, during REM sleep, which is rapid eye movement sleep, will have noradrenaline produced by your locus coeruleus. When you're awake, a number of nuclei, but predominantly your pedunculopontine tegmental nucleus, will produce your acetylcholine and your glutamate. And your acetylcholine, for example, acts via the thalamus to excite the cortex, and that causes you to be awake and alert, as these are excitatory neurotransmitters. So hopefully that's given you an understanding of approximately how the reticular formation works and how the brain stem is organized. And don't forget to also try and remember the way that the blood supply to the brainstem works by looking at the circle of Willis, and therefore that will give you an understanding of the different things that different lesions can cause.